Hello?
Hello. We're going to dive into a system design interview. Here's the challenge. Design Netflix. Think about how users stream videos, how content is recommended, how we handle huge amounts of data, and how we scale to millions of users. Let's get started. What do you think are the key requirements for the system?
So let's start off with functional requirements. So let's say that Netflix, we need to stream. Users need to browse the content, right? And then let's add some more stuff to that. So user profiles, should we have authentication in the scope of the interview?
Yes, authentication should be in scope. So we have streaming, content browsing, and user profiles with authentication. Let's lock those in. Anything else you want to add to the functional requirements before we move on?
I think that would be all. So now let's go into non-functional requirements, shall we?
Good. Let's move on to non-functional requirements. Think about performance, scalability, availability, and latency. What do you think we should consider here?
So non-functional requirements, let's say we need to hold around 200 million users for this system monthly.
Understood. We need to handle around 200 million monthly users. That's a major scale. We should consider high availability, low latency for streaming, and global distribution. Let's keep those in mind. You're doing well. Continue.
Okay, so we scale globally. We want to make sure that our videos can go, they can run 99% of the time, so we need 99% uptime. And let's also consider latency. We want video startup to be less than 2 seconds on average. Will that work?
Yes, that works. We've got global scale, 99.99% uptime, and video startup latency under 2 seconds on average. These are solid non-functional requirements. Now let's start diving into your design.
All right, so let's start off with a brief design. So let's just say we have one of our users here, right? So if we're considering a global scale, first of all, we're going to need to have some load balancing. So this is just to handle all the traffic that's occurring from all of the areas, such as the US, Europe, Asia, etc.
Good start. Load balancing is crucial to distribute traffic across regions. Now think about what kind of load balancer. Global load balancers, regional load balancers, and how they route users. Also, consider where content is served from. What do you want to add next?
So now let's talk about, yeah, where the content is coming from. So we know CDNs are content delivery networks, but what they really mean is places that content can go so that you can fetch it from a shorter distance. So people from Asia can get videos quicker because there's a data center in Asia or any other area for that matter.
Exactly. CDNs place content closer to users, reducing latency. We'll need a network of CDNs distributed globally in North America, Europe, Asia, and more. So now we have users, load balancers, and CDNs in the picture. Let's keep building from there.
All right, let me just add that real quick. So let's just add a few just regional CDN just to indicate that. Okay.
Great. I see you're adding those regional CDNs. That's exactly what we need. Now that we've got the content delivery layer in place, how do you want to handle user authentication and profiles?
Okay, so I think now I'm just going to connect a few things. So we're going from this load balancing and we're connecting to these different CDNs. So from this standpoint, we're going to have basically these videos are served to people directly from this point. So we're going to have these are going to store the videos, but where do we actually store the videos? In what format, I mean, is probably the next area. So for this, I would consider using blob storage or an S3 database simply because we would need to store these videos in a format which is very scalable for all types of video content such as TV shows, movies, etc.
Exactly. Using something like blob storage or an S3 compatible solution makes sense for storing the video files themselves. It's highly scalable, durable, and can handle large volumes of video content. So now we've got the storage layer for the actual video assets. Let's keep going and think about how we manage metadata for each video. Titles, descriptions, recommendations.
Okay, I'm just going to add a service real quick from... Actually, I'll connect the blob storage to the CDNs, but first, I want to talk about how the actual blob storage should be sharded from my point of view, because we simply have so many people, and scaling the database horizontally compared to vertically, which just means splitting the database across many different instances instead of relying on one and stacking that up would be a much better fit in this situation, simply because it allows for faster retrieval and keeps costs low.
That's a solid approach. Sharding the blob storage horizontally will help handle the massive scale and ensure faster retrieval times. So now you've got a good foundation. Load balancers, CDNs, and sharded blob storage for the video content. Let's move on to the metadata service. How do you want to design that part?
Okay, hold on. Let's think about now. We have the CDNs, but actually, let me actually add something in between. So we're gonna have the regional CDNs, and then we're gonna have the content fetching service, in which is just going to be the difference between fetching from the metadata or fetching for the actual video, and those two are actually going to be connected as well. So we'll have the metadata and we'll have the blob storage in separate databases, but they will be connected with this fetching service.
Good. You're introducing a content fetching service that acts as a bridge, coordinating between the metadata storage and the actual video blob storage. That's smart. This service will help route requests, whether it's fetching video files from the blob storage or getting metadata like titles and descriptions. Now we've got a clear flow. User hits a CDN. The content fetching service determines where to pull data, and it interacts with both the metadata store and the blob storage. Let's confirm. Do you want to go deeper into how the metadata storage is structured, or focus on scaling the content fetching logic next?
So let me establish some metadata real quick, or the schema for that, sorry, the video metadata. So we'll have a video ID that just serves as an identification. We'll also have some, let's just say a times viewed, just to indicate for our recommendation system as well. But is that out of scope for this interview? Am I right?
Including something like times viewed is definitely in scope because it can tie into a recommendation system later. So we've got video ID, times viewed. Both are great fields for the video metadata schema. You can add more fields if needed, like title, description, or duration. Once you're done setting that schema, we can dive into how the fetching service will query it.
All right, so I have that for the actual video metadata. So now, can I just add a black box for recommendations, since we're not necessarily focusing on that for this interview?
Yes, absolutely. You can just add a black box for the recommendation system. We don't need to dive into its details right now. That keeps us focused on the core parts of the system. Go ahead and add that placeholder.
All right, so now we have that out of the way. So let's continue on with our requirements. So we have the actual storage of the video. So let's talk about some streaming now. Shall we do that?
Yes, let's dive into streaming. We need to consider how the video is actually delivered to the user in real time. Think about streaming protocols, buffering, adaptive bit rates. How do you want to approach the streaming layer?
So we're going to have two types of users, correct? We're going to have the user that is actually actually viewing the content versus the ones that are uploading the content. So let me just show how that would work. So we'd have an encoding service if you're actually uploading a video. So what this does is it basically converts that raw footage that you gave it, and it converts it to many different resolutions so the user can see how that would work in their specific situation. So you'd have 4K or 180p or 720, etc.
Exactly. The encoding service is crucial for generating multiple resolutions and bit rates: 4K, 1080p, 720p, and so on. This enables adaptive bitrate streaming, so the user can get the best possible quality based on their network conditions. Now we've got both sides: the content upload side with encoding and the content viewing side with adaptive streaming. Let's connect that to the streaming layer now.
Okay, so the encoding service we'll just have it go through a quick queue. So that would just be, let's just consider doing something like Kafka, simply because it is just an industry standard. So we'll just have a Kafka queue that takes in all of the encoding for the videos, and it basically has that in line. And actually, I probably should put the queue before the encoding. Let me just do that.
That makes sense. Placing the Kafka queue before the encoding service is a solid choice. It helps handle the load and smooth out spikes in video uploads. The queue will feed into the encoding service, which will then produce multiple resolutions and formats. After encoding, the processed video files can be pushed to the blob storage and propagated to the CDNs. Now we're tying the upload and streaming flows together. This is coming along well.
Okay, I'm just gonna put a note that the Kafka queue has load balancing in it, just to indicate that. Okay. So then I'll connect the encoding service to the blob storage, and I'll just connect it to video metadata. We'll have the metadata go with the actual encoding, just like as a passage. Would that work?
Yes, that works. The encoding service can update the video metadata as it processes the video, adding details like available resolutions and bit rates. So connecting the encoding service to both the blob storage and video metadata makes perfect sense. That way the metadata stays in sync with the actual video files. This integration is key.
All right, so we have the two types of users. The first one is the user that's uploading, and then we'll have, again, the second one who is just there to watch the videos. So user that is. All right, so now let's look at the next idea. So we have a few of those, and I'm going to discuss now, I think, user authentication. Would that be a good passage now?
Yes, that's a good next step. We've covered content flow: uploading, encoding, storage, and streaming. Now let's dive into user authentication. Think about how users log in, manage profiles, and how we secure sessions. What's your approach for handling authentication at scale?
Okay, so I think there's two parts to this. There's the part of authentication where we need to check the subscription to make sure that's active, and we also want to use, I think we can just indicate, let's just say we have an app server just as part of this authentication, and then we'll have that, and then let's just connect the app server to the actual, let's just connect it to an external API, which all this does is it checks the subscription to see if it's valid or not. Does that sound good?
Yes, that sounds good. Splitting authentication into two parts makes sense. First, verifying the user's credentials and profile on the app server. And second, validating the subscription status via an external API. That way, you ensure the user is both authenticated and authorized to access content. This is a scalable approach for managing millions of users.
All right. So now let's consider. So we have the subscription check, but now we'll have the app server, and this app server kind of feeds back to the load balancing because all this is being done under the app server, but it's just being sent off to the CDNs to get that self-fetch back. So do you want me to connect the app server to the load balancer just to indicate that?
Yes. Go ahead and connect the app server to the load balancer. That shows the flow clearly. Once the user is authenticated and their subscription is verified, the app server hands off to the load balancer, which directs the user to the appropriate CDN for streaming. This ties the authentication flow back into the content delivery flow. That's a strong design choice.
So, okay, now let's talk about user metadata. So, again, I think we should shard this definitely, simply because we have so many users in our system. And now let's discuss some of the schemas. So, for the schema of this user metadata, I think we can have just a few things. So, let's see. We'll have the actual user ID, the subscription status. We could have recently watched videos or movies, whatever. We could have like content. Do you think that's good? Or what else do you think that's in scope for this?
Yes, that's a solid start. User ID, subscription status, recently watched, and liked content are all in scope. You might also consider adding user preferences, such as language, favorite genres, or device types, to help with personalization and recommendations. But what you have now is definitely a good core schema for user metadata.
All right. So now let's consider just some quick API routes. So we could actually have this type of system in production. So let's look at some of these APIs that will be called in this actual system if it was actually Netflix. So we have the get, and I'm just gonna outline these real quick. So we'll have the get to the content. So we'll have the video ID, and I think we should include the region in this. So we'll have the video ID, and then we'll include the region into this. So just to get it from a correct CDN. And then the posting, that's mainly going to be from the backend for actually uploading. So let's just say upload, and then we'll have slash. Actually, we'll just have that, and then the body will just be the raw video data. And then let's say we'll have get slash, and let's just have the user ID again, and let's just have the subscription. So, sorry, let's just get the slash subscription, and then slash user ID, just to verify that. API routes, sorry. Go ahead.
All right, that's a solid outline. You've defined key API routes, a get for content by video ID and region, an upload endpoint for raw video data, and a get for subscription verification by user ID. These cover the core interactions: fetching content, uploading content, and verifying the user's subscription status. This gives a clear picture of how the system's front end and back end would communicate. You've got a strong foundation here.
All right. So I think now I think we have the high level down. You just want to look at it real quick, just to overview everything. And I think we can just dive into some performance scaling stuff, and then we could talk about trade-offs, and then finish the interview.
Here's the overview. We've got users connecting through a global load balancer, hitting regional CDNs for streaming. There's a content fetching service that pulls from sharded video metadata and blob storage. The encoding service, behind a Kafka queue, handles uploads and produces multiple encodings. We've also got an app server for user authentication that checks subscription status via an external API and connects to sharded user metadata. Your schemas for video metadata and user metadata are defined, and the core API routes are outlined, fetching content, uploading, and checking subscriptions. We've got a full picture of the high-level architecture. Now let's dive into performance, scaling, and trade-offs.
All right, so for scaling, again, Netflix is a massive scale globally. We have addressed this using the regional CDN, for this, and this would also include caching. So if a video is fetched a lot, so let's just say there's a new Love Island release in North America, and people are watching that a lot, we'll have caching for the regional CDN right there. And that will just be from a monitoring service. So actually, let me outline this real quick. So monitoring service will watch uh, they will watch the CDN just to see which videos are getting recommended the most, etc. And based off of that, they'll notify the CDN to actually cache those videos. So that's not too much to get that from the blob storage every single time. Because after an upload, the videos aren't necessarily going to be changing, if I'm correct on that.
You're absolutely correct. Once a video is uploaded and encoded, it's generally static content. So caching it heavily in the CDN, especially for popular content, is a key optimization. The monitoring service identifying trending videos and pushing them into the CDN cache reduces latency and offloads the blob storage. This approach scales well and ensures smooth performance even during peak demand.
Okay, so I think for cache and validation, we should probably have a period of like around a month, because popular videos or movies, they're not necessarily popular for a year or so. They're only really popular for that amount of time. And we want to make sure our cache is lightweight so that we're not forcing too much storage on that cache. And we want to keep the whole experience clean, even if you are watching something new. So I think we should just have cache and validation at around 30 days.
That makes a lot of sense. A 30-day cache and validation window strikes a good balance, keeping popular content readily available during peak demand, while ensuring that older or less popular content doesn't consume unnecessary cache space. This keeps the system efficient and responsive, even as viewing trends shift. That's a well-thought-out approach.
All right, so I think now we should just talk about trade-offs and bottlenecks here, and then we should be good.
Perfect. Let's talk about trade-offs. One key trade-off is between storage cost and performance.
Yeah. Oh, sorry. So the trade-off, yeah, I agree. I think the main thing here is if we have some massive influx of people, we want to make sure that our system doesn't crash, because again, one of the main non-functional requirements is that we have 99.99% uptime. So even if a video or a movie is uploaded even a little bit later than it should be, we want to make sure that everyone can still experience the application normally. And if we're able to do that, I think the global load balancer plus the CDN approach works well in this scenario. And again, bottlenecks, the Kafka queue will handle a lot of the influx of uploading, but the situation for Netflix isn't as dire as YouTube, for example, because YouTube, there are billions of people on the platform, and a lot more people are uploading compared to Netflix, which it could be just a few companies. So I think that's also one of the main bottlenecks, but we have systems in place to make sure that it doesn't overrun the system.
Exactly. You've identified the key trade-offs and bottlenecks well. The global load balancer and CDNs handle the massive scale for viewers, while the Kafka queue absorbs spikes in uploads and encoding. And you're right, Netflix's upload volume is more controlled compared to platforms like YouTube. That means we can focus on ensuring high availability and consistent performance, even during traffic surges. You've got a solid plan to handle both the viewing and uploading sides, with mechanisms in place to keep the system stable under load. This design is robust.
All right. So I think that's all. But thank you for your time for this interview. I look forward to seeing back from you. So thank you.
You're welcome. You've done a great job walking through this design. We covered the core requirements, scaling strategies, and trade-offs. You've shown strong thinking around performance and bottlenecks. Good work, and best of luck going forward.
Thank you.